Hey guys, welcome to Pre-Calc, lesson 9.1, Intro to Trig. So we're going to start this intro to trigonometry with standard position angles. Standard position is an angle whose initial side, which would represent this, is the positive x-axis. So that's locked in. This is called the terminal side, and that can spin around kind of like the minute hand on a clock. So an angle is positive if it's measured in a counterclockwise direction, so that direction. If you were to start here on the initial side and go that way, that's a positive angle. An angle then is negative if measured in a clockwise direction. So clockwise goes this way. So if I were to start here, the initial side, and go around this direction, that red angle would be negative. Okay, so what we're going to do first here is draw each angle in standard position, state the quadrant the terminal side lies. Well, quick background. Today we're going to be talking in degrees. We need to realize that that's 0 degrees. Up top is 90. That's 180 degrees. That's 270 degrees. And then back all the way around would be 360. Also our quadrants. First quadrant, upper right. And then we have second, third, and fourth. So all we're going to do here is just draw the terminal side and state what quadrant it's in. We also have to indicate what direction we went. So 210 degrees is obviously between 180 and 270. It doesn't have to be exact. You just need to draw it in the appropriate quadrant. That's obviously quadrant 3. And I went this direction, so draw an arc to indicate that. 75 degrees, that is in the first quadrant. And we went in the positive direction. Negative 20 ends up being in the fourth quadrant. We went the negative direction, so indicate that. Negative 250, we have to think about this one a little bit. Negative 250 is between negative 180 and negative 270, so we're going in the negative direction, right? Think about how this works, 90, 180, 270, but if you go in the negative direction, that's negative 90, that's negative 180, and that's negative 270. So negative 250 is between those two. It would be right there. All right, draw that in, indicate you went the negative direction, and that's obviously quadrant 2. 340 degrees is almost one complete rotation. We're in the fourth quadrant. We went all the way around to there, so indicate that. All right, next. The terminal side of an angle can make more than one complete rotation. So let's draw in one angle here. Let's say that's 45 degrees. Well, over here, what we're going to do is we're going to draw on that same terminal side. But that's not a 45-degree angle. Why not? Because in this case, let's suppose we went around one complete rotation and then ended up here, like so. So what happened is you went 45 degrees plus 360 degrees. So that ends up being 405 degrees. So we say these two angles are coterminal because the terminal side is the exact same. I could make this a 45-degree angle, or I can make it a 405-degree angle. So coterminal angles are defined as angles that share the same terminal side. And there's an easy way to calculate them, and that is by adding or subtracting 360 degrees. To visualize adding or subtracting 360, let's go back to this example here. I can make this a 45-degree angle, or I could add 360, or I could add 360 and another 360, so you can go around any number of times. Those of you that skateboard or enjoy snow sports understand the different revolutions, 360, 720, 1080, 1440, so on and so forth. Those are just complete revolutions. We can do the same thing with angles. All right, example 2. Draw on the same set of axes and state the coterminal angle for each of the angles drawn in example 1. But we don't need to do each one. Let's just take the angle from 1A first. That was 210 degrees. So that right there is 210 degrees. I went that direction. So I'll use different colors here to illustrate what we could do. Well, I could also go that direction. How would you calculate that angle? 210 degrees minus 360, which gives you negative 150. So that red angle right there is negative 150. Well, another thing you could do is you could go around more than one time and end up here. How would you get that? You would take 210 plus 360. So that would give you 570 degrees. Okay, let's see if I can do one more. Let's pick C. I'll try to do this one a little bit smaller. C was negative 20. So there's negative 20 degrees, and I went that direction. Well, what could you do? I could add 360, so I could go around this way. That would be negative 20 degrees plus 360. So obviously that's 340 degrees. That green angle is 340 degrees. Or what could you do? You could subtract negative 20 degrees minus 360 degrees is negative 380 degrees. How would you get that? You would do this. All right, so there are a couple visuals of how you get coterminal angles, but for the most part, you just have to calculate them algebraically. You won't be sketching these all the time. It'll be a little quicker just to do that. Example 3, name two angles, one positive, one negative, that would be coterminal with 570 degrees. So I'm not going to draw this one. We are going to just subtract 360 degrees until we get to two coterminal angles. So we start with 570 minus 360 degrees, and that is 210. So there's one. That's a positive angle, coterminal with 570 degrees. Now, if I need a negative one, I'm going to start with 210 and then subtract 360 from that. 210 degrees minus 360, and that is negative 150 degrees. So there are two angles coterminal with 570 degrees. Example 4, which of the following would not be coterminal with negative 60? So one process you could do here is just keep adding and subtracting 360 degrees until you can find all the ones that are coterminal and then circle the one that's not. Or if you visualize this, negative 60 would be in the fourth quadrant. One thing I notice is that 60 degrees is in the first quadrant. So there's no way these two can be coterminal because they're in different quadrants. That's why that one is not coterminal. All right, getting to the heart of today's lesson, the unit circle and what we call quadrantals. There's a reason that this is called the unit circle, and that is because the radius of that circle is 1. All right, this length from here to here is 1, which means I can find the coordinates of these 4 points. The coordinate here at 0 degrees would be 1, 0. The coordinate at 90 would be 0, 1. The coordinate at 180 would be negative 1, 0, and the coordinate at 270 would be 0, negative 1. So what we're going to do now is we're going to play a little Pythagorean Theorem game. This point right here has generic coordinates x, y. Well, if you think about it, if this coordinate is x, that means I had to go over x in that direction. And if my y coordinate is just y, I had to go up y in that direction. So I can label that triangle x, y. So now take a look at this. It's obviously a right triangle. And your Pythagorean theorem, you know, is a squared plus b squared equals c squared, or more importantly, leg squared plus leg squared equals hypotenuse squared. One leg is x, one leg is y, my hypotenuse is 1. So using my Pythagorean theorem, I get x squared plus y squared equals 1 squared. Okay, now let's flash back to, geometry, algebra 2, and talk about Sohcahtoa. Sine, cosine, tangent. Sine of the angle is opposite over hypotenuse. Cosine of the angle, adjacent over hypotenuse. Tangent of the angle, opposite over adjacent. We'll look at where your angle is, right here. What do we know? This is opposite. That's adjacent. That's hypotenuse. I've got an x, a y, and a 1. Let's use those to figure out these trig ratios. Okay, opposite over hypotenuse. Y over 1, and that's just y. Adjacent over hypotenuse, x over 1, which is just x, and opposite over adjacent is y over x. So what does that tell us? That tells us that sine is equivalent to y, that cosine is equivalent to x, and that tangent is y over x, or sine over cosine. So going back to our unit circle here, what do we know? Sine is y. Sine is y. Cosine is x. Cosine is x. So this coordinate right here I can rewrite actually as cosine theta comma sine theta. Which means, and this is super important, so I'll use green, every point on the unit circle can be expressed as cosine theta comma sine theta. That is super important because we are going to find cosine and sine and tangent of various angles around the unit circle using coordinates. All right, so we need to make that connection. Again, just to emphasize this, because it is so important, we're going to be using it all unit long. If you're dealing with the unit circle, meaning the radius is 1, the x-coordinate is cosine theta, the y-coordinate is sine theta. And again, remember, theta is just the angle. So when I say theta, I'm talking about this angle right here. The angle between your initial side and your terminal side. It could be in quadrant 1, could be in quadrant 3. This would be theta. Could be in quadrant 4. That would be theta. All right, it's just wherever that angle ends up in the unit circle. So let's go back to our Pythagorean theorem here. And instead of x and y, let's talk about sine and cosine. All right, I'm just going to change the order a little bit. But since y is the same as sine and x is the same as cosine, my Pythagorean theorem from up above can be written as the following. Sine squared theta plus cosine squared theta equals 1. And that is critical. That's our Pythagorean identity. From there, we have two offshoots, all right? Let's solve for sine squared theta. If we want sine squared theta by itself, we would just subtract cosine squared from both sides, and we get 1 minus cosine squared theta. The other offshoot is if you want cosine by itself. Cosine squared theta equals 1 minus sine squared theta. We are going to be using these all unit long. You've got to memorize them. Now let's apply what we just learned in example 5. I'm starting with a blank unit circle. I want you to fill the following in. Let's talk about our quadrantal angles. That means angles that are not in a quadrant. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. I don't need to fill in the quadrants, but one other thing I will do is write down the coordinates. Coordinates of that point right there, 1, 0. At 90 degrees, that's 0, 1. At 180, it's negative 1, 0. And at 270, 0, negative 1. So the other thing I want to remind you guys, every coordinate can be written on the unit circle, can be written as cosine theta, comma sine theta. We are going to use all of this information to evaluate these without the use of a calculator. So here's how it works. Sine of negative 180 degrees. First thing you need to do is determine where is negative 180 degrees. Oh, it's right there. It's the same as positive 180. Next thing you have to realize, sine is the y-coordinate of that point. There's negative 180. What is the y-coordinate? Right there, 0. So sine of negative 180, boom, 0. It's not a lot of work, but you have to visualize this. Sine of 0 degrees. So again, where is 0 degrees? 0 degrees is right here. Okay, what's the coordinate? 1, 0. I want sine. Sine is the y-coordinate. The y-coordinate there is 0. So sine of 0 degrees is 0. Cosine of negative 90. Where is negative 90? Well, that's positive 90, so negative 90 is down here. Negative 90 and 270 are what we call coterminal. So I'm looking at this coordinate. I want cosine. Cosine is the x coordinate. So I want that right there. Cosine of negative 90 is 0. I will skip the tangents. I want to focus just on cosine and sine, then we'll go back to tangent. So let's skip down to this one. Cosine of 180. Find 180. Oops, sorry. 180 is right here. What's the coordinate for 180? Negative 1, 0. I want cosine. Cosine is the x coordinate at 180, so that's negative 1. Cosine of 180 is negative 1. Sine of negative 90. So we already talked, negative 90 is right here. There's my coordinate. I want sine. Sine is the y value. There's the y value, negative 1. So for tangent, there's a couple ways you can do this. Tangent's very confusing. That's why I skipped it. Now we're going back to it. You can memorize tangent as y over x from the previous page, or I kind of think of it as sine over cosine. So I'll think of this as sine of negative 180 over cosine of negative 180. Now, if we've already done these, we can fill them in. We already did sine of negative 180 up above. That's a 0. Cosine of negative 180 is the same as cosine 180, right? That's negative 1. So in a fraction, I can't leave a 0 in a fraction. If 0 is in a fraction, the answer is either 0 or it's undefined, depending on where the 0 is. If the 0 is in the numerator, that result is 0. Tangent 270. Well, I'm not going to bother writing this out again, but I know it's y over x or sine over cosine. Here's 270. Sine over cosine. Y over x. That's negative 1 over 0. If 0 is in the denominator, that's undefined. Now, here's one thing you can kind of think of. I kind of use this as an aid to help me remember tangent, because I think it's more challenging than sine and cosine. Tangent equals y over x, which is equal to slope, right? Think of slope, delta y over delta x. This is a horizontal line. The slope of this horizontal line is 0. So that means tangent would equal 0 here and here on this horizontal. So when someone asks me for tangent of 0, 180, or 360, I'm thinking, oh, that's on a horizontal. Slope is 0, so tangent 0. On this vertical, slope is undefined for a vertical line. So that means tangent is undefined for 90 and 270. So if you're asked for a tangent value on this, undefined. Tangent value here, 0. That's just one tool I use to help me memorize those values. Okay, so now example 6 and 7, they're just going to put what we did up above into a simple algebraic expression. Find the value of 3 sine 180 plus 4 cosine 180. So basically what I do here is just rewrite this 3 times something plus 4 times something. I'll kind of scroll up to this unit circle. Sine of 180, there's 180. There's the coordinate for 180. Sine is the y value. So that's a 0. Plug a 0 in here. Next would be cosine 180. Well, that's kind of nice. We're using the same point. Cosine is the x. That's a negative 1. So I plug a negative 1 in here, and you just evaluate that. 3 times 0 is 0. 4 times negative 1 is negative 4. So you have 0 minus 4. Answer is just negative 4. So again, obviously, this would be done without a calculator. Next, evaluate tangent 180 minus 6 sine negative 270. So I'll have something here, minus 6 times something. Tangent 180. Well, I just gave you guys that little tip. The slope of that line right there is 0, so tangent of 180's got to be 0. Sine of negative 270. So negative 270 is the same as a positive 90, right, if you go the negative direction. So let's go up here to 90. There's my coordinate. Sine is the y value. I want the y value there. That's 1. 0 minus 6 times 1 is negative 6. The last thing we'll talk about today, signs, S-I-G-N, of the trig ratios in the quadrants. So what we've been kind of emphasizing all lesson long is that every coordinate can be considered cosine theta, sine theta on the unit circle. All right, think of that as your x and y. And think about your quadrants and where x is positive and where y is positive. So in quadrant 1, sine theta would be the y coordinate, the y is positive. Cosine theta would be the x coordinate, that's positive. Tangent theta is sine over cosine, positive over positive, so that'll be positive. In the second quadrant, sine theta is still positive because the y is positive. Cosine theta is negative. So tangent theta, which is sine over cosine, a positive over a negative, is negative. Third quadrant, they're both negative, right? Negative x, negative y. So sine theta is a negative, cosine theta is a negative, but check this out, tangent theta would be positive because a negative divided by negative gives you a positive. In the fourth quadrant, x is positive, y is negative. So sine theta is negative, but cosine theta is positive, which then makes tangent theta negative because you have a negative divided by a positive. So the reason we wrote all this out, we're not going to do this again, is to help us come up with a system to remember where these are positive and where they're negative. So if you notice here, all of them are positive here. Sine's positive in the second quadrant. Tangent's positive in the third. Cosine's positive in the fourth. So we're going to come up with something to help us remember that. A, S, T, C. It's an acronym. You're going to hear me say that over and over again in this unit. A, S, T, C. Now, there's lots of funny phrases that you can memorize to help you remember ASTC. All students take calculus. All stores take cash. There's other colorful phrases if you want to dig a little deeper. But basically, you have to remember ASTC stands for where those particular functions are positive. So I like to put little pluses by them. A stands for all. They're all positive. S stands for sine. So when you think S in the second quadrant, you're thinking sine's positive, which means the other two would be negative. T's positive in the third quadrant, so that means the other two have to be negative. Cosine's positive in the fourth, which means the other two have to be negative. So it's important to memorize this because we need to come up with these signs, S-I-G-N, very quickly. So check out these last couple examples. Is cosine x plus 180 positive or negative if x is an obtuse angle? Well, that's very hard to visualize. So what I like to do is if you're given something, like in this case, an obtuse angle, just make up an obtuse angle. I think an easy one to work with is 100 degrees, right? Anything between 90 and 180. So then if x is 100 degrees, x plus 180 would be 100 plus 180, which is 280. So now, where is 280 degrees? So if you think about it, there's 0, 90, 180, 270. So 280 has to be in here. I'm talking about an angle in the fourth quadrant. Remember your ASTC, and that is cosine. So is cosine positive or negative? It's positive. Don't expect to be able to go away from here and say, oh, positive or negative. Think about it. Put yourself into the unit circle to see what quadrant you're in, and then remember your ASTC. All right, so the next type, in which quadrant is cosine theta greater than 0 and sine theta less than 0? Before I even begin this, if it says in which quadrant, here's what I do first. Quick sketch, ASTC. Get in the habit of writing that down. You're going to do that a lot in this unit. Next thing, we have to interpret inequalities. Greater than 0, what does that mean? Greater than 0 means positive. So I want to know, where is cosine positive? Cosine's positive where they're all positive and where cosine's positive. So what I'll do is I'll circle those two quadrants. That is those are the two quadrants where cosine is positive. Now, what does it say about sine? It's less than 0. So that means sine is negative. where is sine negative? So we got to think about this. Sine is negative on the opposite quadrants where it's positive. So since it's positive here and here, I don't include those. Sine is negative in these two quadrants. So now you just have to find the quadrant that contains both of those, and that's quadrant 4, right? Don't write down C. It's quadrant 4. If you notice, double check. Cosine's positive, yep, check. And sine is negative, check. All right, guys, that concludes the first day. This unit is super important. It's not overly difficult, but it contains a lot of material, requires a lot of memorization. So please take time, take thorough notes, and take some time to do the homework. I know we don't collect it, but it's very important that you get that practice and you get that repetition. As usual, if you have any questions, don't hesitate to reach out. Thanks a lot for watching. We'll see you in class soon.